Hey everyone, this is Dr. Walker. This is video 561 on electrical measuring instruments. And all we're going to be talking about in this video is just how to use a voltmeter and an ammeter to measure voltage and current, respectively. So when you're trying to measure voltage, you're going to use a voltmeter. You might have a multimeter that has different settings, and one of them is for measuring voltage. So the voltmeter is going to measure the potential difference between 2 points. So the important thing about this, if you're doing a lab, is to connect it correctly. So voltmeters must be connected in parallel with whatever they're measuring. So in this picture, this voltmeter would be measuring the voltage across R2. And ideally, the resistance of the voltmeter is infinite, right? Because if you have a lot of resistance here, R is very high, then you're not going to have barely any current here, which is what you want. You want all of the current to go through R2 so that it can measure the voltage correctly. If the voltmeter does not have a high resistance, then some current will go here and some current will go here, and now you're not getting the accurate voltage reading on resistor 2 because not all of the current is going through it. But for practical purposes, the resistance of the voltmeter is just a lot higher than any of the resistors in the circuit, and then it's fine. Now, when we're measuring current, we're using an ammeter. And the ammeter is a lot different from the voltmeter. It's going to measure the current passing through it. So it must become part of the circuit. It must be placed in series in the circuit. So that's the really important distinction. So usually if you have a wire connecting the battery here and the resistor, let's say you have a wire connecting it, you would just take that wire off and put one end of the ammeter on one side and one end on the other, so that it completes that circuit. So ideally, an ammeter would have zero resistance. That way it doesn't change the current that's flowing, right? If the ammeter has a lot of resistance, then you're not going to get as much current out of your battery. Remember that resistances add in series. The more resistance you have, the less current. So you don't want the ammeter to alter the reading that you're trying to make. So ideally the resistance is zero, but for practical terms, it's just going to be a lot smaller than any of the other resistances in the circuit. Let's take a look at a couple of questions. This first question says, what does the voltmeter read? So go ahead and pause the video and think about it. We have a voltmeter that is placed in parallel across the resistor. So we're trying to measure the voltage across the resistor. And the resistor is getting the full voltage from the battery because it's connected in parallel. So the voltmeter is going to read 6 volts because that's how much voltage the battery is giving to the resistor. How about this question? What does the ammeter read? So take a minute and think about it. So we said that the ammeter had to be placed in series in the circuit. It cannot be placed in parallel. So what's going to happen here, remember that the ammeter has very, very low resistance. That means very, very high current is going to go through here, and you're only going to have a tiny bit of current going through here, right? Current takes the path of least resistance. So by putting the ammeter here, it's kind of like a short circuit. You're going to have a huge current, and it will probably fry the meter because it's probably not going to be designed to handle that much current. So the takeaway message, just make sure to put the voltmeter in parallel and the ammeter in series so that you can measure your voltages and your currents correctly in your circuit.